let us do a combination sum where the condition is either in or out. What do you mean by in or out? Let us see with this sum. Okay. A committee of 6 people which must contain at least 4 men and at least 1 woman is to be chosen from 10 men and 9 women. You came across information, write it down. Given to us is 10 men and 9 women. You need to select 6 people from this. Clear? And your selection should satisfy this condition. The condition is at least 4 men. At least 4 means 4 or more. Mathematically, how do we write? We write greater than or equal to 4. This inequality satisfies at least 4. Next, and at least 1 woman. At least 1 means 1 or more. Mathematically, how do we write greater than or equal to 1? Clear? This is what is given so far. Now the first bit. Find the number of possible committees that can be chosen. My selection of 6 satisfying this condition. How many such committees can be chosen? You need to find out. I get multiple options satisfying the condition and the count of 6. To show all such options, I will make a table in this way. See. Now, whatever number I write here should satisfy this condition. Whatever number I write here should satisfy this condition. And when I add these two, the sum should be 6. Clear? So let us start writing all such set of numbers satisfying the condition and the count of 6. Okay. Now, at least 4. So I start with 4 here. So here it has to be 2. Then only the count will be 6. 2 satisfying this condition, yes. So this set of numbers is accepted. So next option. Increase this to 5. Here it has to be 1. Then only the count will be 6. This 1 is satisfying this condition. So no issues. Let us go to the next option. If I increase this to 6, then here it has to be 0. Then only the count will be 6. But this 0 is not satisfying this condition. So what we do is we reject this condition. We reject these set of numbers. So conclusion is I get only these two set of numbers satisfying the condition and the count. Okay, now over here from 10 men selecting 4, in how many ways can it be done? It can be done in 10C4 ways. Okay, next. From 9 women you need to select 2. That can be done in 9C2 ways. Okay. Now, it is 4 men and 2 women. There is and. So, whenever it is and, you need to put into sign. Okay. Now, same for the second row. From 10 selecting 5 can be done in 10C5. From 9 selecting 1 can be done in 9C1. It is 5 men and 1 woman, so it's into between them. Clear so far? Next. It is these set of numbers satisfied the condition and the count. Okay. Or this set of numbers satisfied the condition and the count. It is or. Whenever it is or, you need to add. So add these two to get the final answer, and that you get is 9828 is your final answer. Okay. Now second bit. Find the probability that one particular man Albert and one particular woman Tracy are both on the committee. Given condition now that you should satisfy is Albert and Tracy has to be present in your selection. And how can you make sure that they are always present in your selection? Set them as priority. Your priority is you should select Albert first and also Tracy. Then only you should see for the vacant positions to fill. Clear? Now I get multiple options here also, so I will make a table. See, given is 10 men, 9 women, you need to make 6. See, this condition is for all the 3 bits. Now, step 1, Albert should be selected. So, let us say Albert is selected. Same way Tracy should be present in your selection. That can only happen if you select her and place in your selection. Okay, now what I do is I make use of first bit table. Earlier 4 men, so now I will make it 3 because Albert has already been, 1 man has already been selected. So earlier 2 men, so I will make it 1 woman because now 1 woman is already present in the selection. Clear? Now second row, earlier 5 men, so now I will make it 4. Since Albert is already present, earlier 1 woman, so I make it 0. Since Tracy is already present. Clear? Now over here, earlier there were 10 men, but now 1 Albert is gone, so the count will decrease it to 9 men. Same here, earlier 9 women, 1 woman Tracy you have taken out and kept in your selection. That means now the woman count will also decrease to 8. Many forget to decrease the count, you should not forget. Okay, now from 9 men selecting 3 can be done in 9C 3 ways. From 8 women selecting 1 can be done in 8C 1 ways. It is 3 men and 1 woman, so it is and, so you need to put into sign. For and we put into. Same way for the second row. For this from 9 you need to select 4, so 9C 4. From 8 selecting 0 is 8C 0. Next, it is these set of numbers satisfied the condition and the count, or these set of numbers satisfied the condition and the count. Whenever it is or, you need to add. So add these two. The final answer that you should get is 798. Okay. But here they are asking you for the probability. Clear? So whenever they are asking for the probability, whatever answer you got, divide it with the total. The total is first bit answer, that is 9828. This is the probability and this is the answer. Okay. Whomever should be there in your selection, that should be your priority one. Take them, place in your selection. Okay. Fine. Now third bit. Find the number of possible committees that include either Albert or Tracy but not both. What did you understand from this? Other way of saying that is, when Albert is selected in the selection, Tracy should not be present. Okay. Or when Tracy is there in the selection, Albert should not be present. Clear? At one instance, any one of them only has to be present. Clear? So let us consider these two situations. See. Again I get multiple options, I will make a table. Same thing. 10 men, 9 women, you are selecting 6. Now see, here condition is same, greater than or equal to 4, greater than or equal to 1. Let us see. When Albert is there in the selection, I am considering this situation 1. I want Albert to be present in my selection. That could happen if I take Albert from here and place it in my selection. Clear? So that will decrease the men count to 9 since Albert has been selected. When Albert is selected, Tracy should be kept away from the selection. So that will decrease the women count. When Tracy is away from the selection, now women count will be 8. Clear? 1 in, Tracy out. In general, both will decrease the men and women count. Clear so far? Now, let us see how many such options do I get. To write options here, I make first bit table. Here it was 4. 1 man is already present, so make it 3. Here no woman is present, so 2 will come. 1 man is already present, so make this 5 to 4. No woman is present, so this 1 will be as it is. This is situation 1. Now situation 2. Again same 10 men, 9 women, you need to select 6. Condition is same, greater than or equal to 4, greater than or equal to 1. Now, in this situation, Albert is away. So when Albert is kept away from the selection, that will decrease the men count to 9. And Tracy has been selected. That will also decrease the women count to 8. Clear? Albert kept away from the selection and Tracy has been selected. Did you understand both the situations? Now here let us see how many such options do we get. Again I will make use of first bit table. Here it is 4 men. No man is selected yet, so 4 will be there as it is. Here 2 women, 1 woman is already selected, so make it 1. Now again second row. 5 men, no man is selected, so make it 5. Here 1 woman is already selected, so make it 0. Clear? So these are the options satisfying both the situations. Now let us write for each. Now over here, from 9 selecting 3 can be done in 9C 3 ways. From 8 selecting 2 can be done in 8C 2 ways. It's and between them, so you put into. Same here, from 9 selecting 4, from 8 selecting 1. It is either this or this, so add these two. So that answer you get is 3360. Okay, now here from 9 selecting 4 is 9C4. From 8 selecting 1, 8C1. It is and, so you multiply. Same way you write for this, from 9 selecting 5, from 8 selecting 0. It is either this or this. Whenever it is or, add. So when you add these two, the answer that you get is 1134. Clear? Now see. There is or in the question as well. It is either situation 1 or situation 2. Situation 1 or situation 2. So to get the final answer, you need to add because there is or. So final answer is 3360 plus 1134. That will result in 4494. This is the final answer. Whenever or, add both the answers.